Welcome back. So I have up here an equation, 2x minus 1 squared equals 12. And I know what you're saying. When you first look at it, you're not sure if it's quadratic because it's just a good old 2x. Well, if we follow our definitions, we know squaring means we would multiply 2x minus 1 times 2x minus 1. And we know as soon as we did FOIL, 2x times 2x would be 4x squared. So we know in our head this is going to be a quadratic equation. Now, the question here is, do I go through and FOIL and then set it equal to 0 and try to factor it, or do I just jump and do the square root method? Well, think about this, ladies and gentlemen. Does factoring always work? No. So I want everybody to understand, even if you did FOIL this out, first would be 4x squared. Outers would be negative 2x. Inners would be negative 2x. Last would be positive 1. Okay, we see it's quadratic. We know when we do FOIL, we collect like terms. Negative 2x is negative 4x. All right, still quadratic. I've learned if I set it equal to 0, I should be able to factor it. All right, 1 minus 12 is negative 11. So there you go. You want to factor this expression. Well, if you look, there's no GCF. It is not difference of perfect squares. It's 3 terms. It's a trinomial. And to make it worse, it's a difficult trinomial. So you would sit there and play the game, or I would play the game. I would say, okay, 4x squared would be 2x times 2x. But wait, it also could be 4x times 1x. And I'm not a mind reader. I'm not sure which option's going to work, so I list both. Then I'd go to my last term, 11, and I would say, okay, well, that's easy. 11's factors are 11 and 1. So I put a 1 and 11 in here. And the only way I know those factors are correct is I have to check the outers and inners. And they have to subtract to make a 4. So if you look here, the outers are 2 times 11, which is 22, and 2 times 1 is 2. 22 minus 2 is not going to give me a 4. Even if I switch and put the 11 here and the 1 here, I still would get 22 and 2. So that option doesn't work. So I'll put the 11 here and the 1 here. Now my outers are 4x, my inners are 11x. 4x and 11x will not subtract to 4x, so I switch them. Now my outers are 44x and my inners are 1x. 44x minus 1x is not going to be 4x. So what this shows me is I did all this lovely algebra work. I FOILed, I got a trinomial, I got a set equal to 0, but it didn't factor. And that's because factoring doesn't always work. So what I want to show you is you can't say you can't solve this equation. You can. You just need a different method. And that's why we have the square root property. If I look, this equation we know has a square, and we know to get rid of a square, we square root. Now, you have to follow the 3 steps correctly. When you use the square root property, step 1 is to isolate the square. The term that belongs to the exponent 2 has to be isolated by itself. Well, if you look, here's the square, and because we're in parentheses here, that means all of this, 2x minus 1, this binomial, belongs to it. So nobody can move. So step 1's done. So all we have to do is go to step 2, which says square root the left and square root the right. Squares and square roots are opposite or inverse operations, which means they cancel out. I think of the square root symbol as a house, and I think of the house, these guys inside, these terms inside are stuck in the house. So pretend the house is on fire. This square is the fireman, and he's going to put out the fire. So the square and the square root cancel out. That leaves us with 2x minus 1 equals. Because you placed this square root symbol in, it was not in the original equation. We must put a plus or minus. Now let's talk. Can we leave a square root of 12? Absolutely not. Even though 12 is not a perfect square, it has in it the perfect square 4 and 3. So the square root of 4 is 2, and the 3 stays inside because we cannot square root it. On the left side, we do not need these parentheses because in front of this is understood to be a 1. So now we have 2x minus 1 equals plus or minus 2 square roots of 3. This is where I'm going to now break it up into two equations. Because remember, our goal is to solve for x, and x is not by itself. So I'm going to write 2x minus 1 can equal positive 2 square roots of 3. 2x minus 1 equals negative 2 square roots of 3. And we know every quadratic equation should have two solutions. Now we just got to get x by itself. So we'll add 1. And now here come the boo-boos. Can you add a whole number 1 to a root? Absolutely not. They're not like terms. Remember we talked about this. In radical world, we like to write the whole number first. So put the 1 in front plus 2 square roots of 3. Over here, when we add 1, same concept. You cannot add a whole number to a root. So in radical world, we like the whole number first, 1, and then that's minus 2 square roots of 3. But we're still not done because we're solving for x. So to get x by itself, we have to divide by 2. All right? We know 2 divided by 2 is going to cancel out. Now here comes the boo-boo. This is what most of you will do. Most of you will come over here and divide this 2 with this 2. And you're going to get marked wrong because you're not being mathematically correct. The division bar goes all the way across, which means I'm not just dividing this term by 2, I'm dividing that term by 2. So people, either they both divide by 2 or you leave them put. So I can write this answer as 1 plus 2 square roots of 3 over 2. Over here, I would write the answer as 1 minus 2 square roots of 3 over 2. Now, that's acceptable because it's one fraction. And that's how we want our final answer to look. Okay? Great. See you in the next module.